So, okay, before that, a quick recap of the shared responsibility model where security of the cloud, right? So the whole security of the entire cloud is AWS responsibility, whereas security in the cloud is customer's responsibility, correct? So where uh, it's again like similar to what a policeman's job is, right? Security of the city or of the town is of the state is police's responsibility, whereas security inside your house is your responsibility, correct? Obviously, you can't expect a policeman to guard your house and ensure that everything is protected. So security within the house. So in this case, security in the cloud is basically all your resources, right? So all your resources such as your EC2 instances, all your VPCs, your databases, your network components, those are all, your resources, right? So that's basically the responsibility of customer. Okay, it is not the responsibility of AWS. That's the responsibility of the customer. That's where you have a very clear line of delineation that says that the orange portions are all managed by AWS. The blue portions are all managed by your own self. Then we looked at security groups. What are security groups? Security groups are instance firewalls. Okay, where in the security group you create a security group and you assign it to an EC2 instance. Okay, security group can be assigned to an EC2 instance or compute instances. And security groups have got three major things: inbound, outbound, ports, protocols, and source, right? Where they originate from. So you can, by default, when you create, when you create an EC2 instance, no traffic is allowed inside the EC2 instance until you associate a security group to it. And within that security group, you say that's a gate, right? Within the security group, you say allow so and so source to communicate with my EC2 instance on so and so ports and so and so protocols. Okay, and you have two types of communication happening: inbound and outbound, right? So inbound is when a client tries to connect to your server. Outbound is when the server sends the data back to the client, or when server connects to the client. Right? Both are required. Okay, so one important thing which I did not tell you yesterday, I didn't tell you purposefully, is that security groups are stateful. Okay, I'll tell you what stateful means. We will spend about 5 minutes on that, and then we'll move to the NACLs. Okay, then what we did, we also created a Linux server. We used your PuTTY from your desktops or laptops to connect to the Linux server, right? By implementing the necessary security groups. And what did we do? We also removed the security group to see if it is pinging or not, right? Immediately we saw that the ping was actually timing out, right? And to enable ping, you have to open ICMP on the security group. To enable SSH, you have to open TCP port 22 on the security group for either. So if you specify 0000 as source, any client will be able to connect to your EC2 instance. I mean, as long as there is a network connectivity. Okay, so this is like a firewall, right? I mean, there has to be a network connectivity. If there is network connectivity, any client, anywhere will be able to connect. I mean, if it is a public subnet, if it is EC2 instance on the public subnet, then you will have wide internet access on that EC2 instance, right? So anybody who has got internet access will be able to connect to your EC2 instance, provided they have the key, provided they have the username, password, or the key to connect to the EC2 instance. Okay, so that way, 0000/0 means any IP address. It is not restricted. If I say 10.51.5.50, then that's a specific IP address. I'm only allowing that client, that IP address, any EC2 instance with, or any server with that client with that IP address to connect to my server. But if I say 0000, which means is any IP address. I think I clarified this yesterday. 0000 doesn't mean an internet gateway, right? 0000 means any IP address. Of course, in this case, when you associate a internet gateway with a subnet using a route which says 0000 to pointing to internet gateway, then that subnet becomes a public subnet like this subnet. And EC2 instances in that subnet can have a public IP address associated with it, and it will have internet access. Whereas the private subnets, which does not have a 000 route to internet gateway, will not have internet access. Okay, so now let's a little bit look into inbound and outbound. Okay, so now usually what happens is when client connects to a server, the client makes a connection to the server, which is called the inbound connection from the server perspective. Okay, and then there is also an outbound connectivity which is established by the server to the client, because it is bi-directional, right? Like if I'm in TCP protocol, the TCP protocol has got a acknowledgement. That's why it is a very robust protocol, right? How many of you know what an acknowledgement is? Can somebody talk about the TCP protocol's acknowledgement?
When we have two nodes, the information is sent from node A to node B, and if again it comes back to the node A, it's called acknowledgement, I think.
Okay, good, very good. Thanks, A24. So basically,
Okay.
what acknowledgement means is when say two nodes are talking to each other. Two systems are talking to each other. When system A is talking to system B in TCP protocol, for every packet that is sent from system A to system B responds back to system A with the acknowledgement saying that it received the packet. Okay, so that system A knows that, okay, I've sent one packet, system B has received that packet, and system B has sent an acknowledgement back. Okay, so in case if the acknowledgement is not sent back on time, or if system A doesn't receive the acknowledgement, then what happens is system A again tries to resend that packet. It again retries. Okay, that retry mechanism is the beauty of TCP protocol. Okay, whereas in UDP protocol, you don't get an acknowledgement, because it's just a one-way communication. It doesn't care. It's like fire and forget. It doesn't care whether there is an acknowledgement sent back or not. It just sends and then keeps quiet. It's up to if the packet is lost in the middle during the network. If there is a small glitch in the network, or if there is connectivity issues, then the packet is lost. Lost packet is lost. It never reaches the destination. Whereas in TCP, it's not the case. Even if there is a network glitch momentarily for a few milliseconds, and if the packets that system A sent to system B were lost, it will still retry, because system B will say that they have not received the packet. Okay, so that's the beauty of TCP protocol. Okay, so now, how does it tie up with the inbound and outbound, right? So now, when a client is trying to initiate a connectivity to server, okay, it first goes through the TCP handshake process. Okay, so now learn about the TCP handshake. This is an important interview question. Okay, of course, it is good if you it's good you're learning cloud, but along with cloud, you also have to learn some of the fundamentals. Okay, so who knows the TCP handshake process? Can somebody explain me the TCP handshake? What are the steps involved in the TCP handshake? Nobody knows. You all have not studied this in your computer science engineering, computer science subject. TCP handshake. Okay, that's a good food for thought for all of you guys. You have to read about TCP handshake because this is a very famous interview question. You go to any interview, you will be asked about TCP handshake. You need to understand what a TCP handshake means. These are all basic fundamentals. Okay, I'll point you to some of the resources maybe after this class, and then you'll be able to get some reading around that. It's quite interesting, right? What are the stages part of the TCP handshake? Okay, so now what happens is when the client tries to initiate a connection with the server, the connection is inbound connection is initiated with the server. Okay, so then server also has to initiate an outbound connection to the client. Okay, so because TCP is a uh, is a very robust protocol which has acknowledgements, right? Which can send an acknowledgement packet back to the client. So from that perspective, when the client is sending say 10 packets, server also has to send acknowledgement for those 10 packets, saying that it received those 10 packets, right? So how will it send? If it is just one way, server will not be able to send it back to the client, right? It's like if you have a road connecting, like say two areas or two localities, if that road is just a one-way road, only one direction, traffic can flow only in one direction, right? But it has to be a two-way road so that the traffic which flows can also flow back from the other locality back, correct? So from that perspective, the server also establishes an outbound connection with the client. And what happens is there's a very interesting thing that happens with security groups. Security group is a stateful security group. What does stateful means? Okay, let me give you an example. Yeah. So let me just copy this. I'm just copying this here. Okay, so now what will happen is this is how we want to allow a putty to from client. I'll just give an IP address to my client. My IP client is 192.168.10.50. That's the that's the IP address of my client. IP address of my server is 10.1.5.8. So that's my IP address of my client server. So now when my client has to talk to server, what will be the rule looking like? What will be the inbound rule looking like? Inbound security group rule. It will look like the first rule will be let's put a table. Yeah. I'm just putting a table here which represents the security group. Okay. Okay. First one is protocol port source. I'll give purpose. So first will be TCP protocol. Port will be 22. Imagine this is a, remember, this is a inbound security group rule. Okay. Port will be 22. Source would be, what will be the source? This will be the source. 50/32. You have to give /32. Let's say SSH. Yeah, this is the rule that you're creating, inbound security group rule that you're creating. And similarly, there will also be an outbound rule. Usually outbound, you don't restrict it. Okay, outbound would be all protocols, all ports 0000/0. This will be like, so usually this will, by default, it will be like this. Outbound will have all. But now let's say I also want to restrict my outbound. Okay. So usually what happens is when you want to restrict your outbound, right? So in TCP/IP, when communications happen between a client and the server, so now inbound port is 22, correct? So now the client is actually making an inbound connection to a outbound connection to a Linux server on port 22. But now when server has to establish a connection with the client, because it has to send the acknowledgement packet back to the client, right? The server has to send it back to the client, correct? So in that case, what the server does is it picks up a random port from the client called ephemeral ports. So every operating system has got a set of range of ports, and they are all short-lived temporary ports. Okay, and they're in the range of some 4,000 to 50,000. Okay, so those are called ephemeral ports. Okay, you need to understand that ephemeral ports very well. Okay, I'll show you. TCP ephemeral ports. Okay, so in this case, if you see, there's a wiki article. You can read through this wiki article. An ephemeral port is a short-lived transport protocol port for internet protocol communications. Ephemeral ports are allocated automatically from a predefined range by the IP stack software. Ephemeral port is usually used by the TCP as the port assignment for the client end of a client-server communication. Note this very clearly, as the client end of a client-server communication. As the port assignment for the client end. Okay, so it's very clear, right? I mean, you have got a client, and this is the client side of the port is called ephemeral port. Okay, so in this case, what happens is, so here the inbound port will be for the server would be 22. Whereas when the server connects to the client, it will be some maybe 5987. This will be the port number which will be used. It'll be an ephemeral. It's called ephemeral port. Okay. So now when the server has to take an outbound connection on 5987, obviously it has to be open in the security group as well, in the outbound security group as well. If you don't open this in the security group, right, your outbound connections will not be that's the impression, right? Your outbound connections will not be going through on the ephemeral ports, correct? Because what happens is when you when the client connects to the server on port 22, and when server tries to connect to client on 5987, you have port 22 open for inbound, and also for outbound on the server side, outbound also has to be open. If you see on the server side, you also have to open 5987 on the server side, so that server is able to initiate an outbound connection on port 5987 to the client. Okay, so that is what is important, right? So that is the reason why you should never restrict the outbound security group rule, right? If at all you want to restrict it, you can restrict it to a ephemeral port range. You can Google for it, ephemeral port range, AWS ephemeral port range for Linux. Yeah, so if you see this, it is 327618. Yeah. Yeah. So if you see here, yeah, ephemeral port range is usually at 327682 to 65535. Okay, and it basically varies from operating system to operating system, right? So if you see, many Linux kernels use 327618, so 768 to 61000, and some older operating systems use a slightly different range. Okay, but the crux of it is, and see if you see, in practice, to cover the different types of clients, to initiate traffic to public facing instances in your VPC, you can open ephemeral ports 1024 to 65535. Okay. So now, in order to cover that, I mean, usually you don't restrict any, port range, beyond in the outbound, because when the client is, when the server is trying to talk to the client, it really doesn't matter, because as I said, the example that I gave you yesterday was that you protect your inbound. When somebody is entering your apartment, that's when you protect. When somebody is going out, you don't protect much, right? I mean, of course, you try and understand, who's coming and who's going. But when somebody is leaving the apartment, you don't really scrutinize as much as the one who enters the apartment, correct? So from that perspective, you leave your outbound security groups as 00. Even if you want to restrict it, what you can restrict it is, you can restrict it to TCP. Port is, you can say 1024 to 65535, and sources, again in this case, right? I mean, if you're running a web server, your web server will be connected from any computer in the world, right? So you have to allow this to 000, because you won't be able to keep whitelisting all the IP addresses that your clients will be connecting to, right? Because imagine google.com or amazon.in is there, right? Amazon.in shopping, e-commerce website is there. Anybody can connect to that, and anybody can subscribe to that, and anybody can start making use of it, right? You won't be able to specifically say that, okay, only XYZ person can connect. Then there is no point in exposing that to a public World Wide Web, correct? So that's why you should, if it is a public websites and things like that, you should just allow 000, so that when any client connects to that, it is able to re-establish the reverse connection on the outbound on an ephemeral port for that specific source. Sorry, it won't be source actually. Outbound will be destination, I believe. It will be given as destination, not source. Okay. So now this is basically the concept of outbound, right? So where you, by default, you don't restrict any outbound, because you only restrict inbound, because outbound is still needed when the server initiates a communication to the client to communicate on the ephemeral port to send the the acknowledgement packets and other things, and it might also use it to send data back to the client, correct? Like you're serving a web page from your web server which is running in Linux, right? And you'll be able to use your web server, and your web server is actually returning, say, hello world as an HTML, right? So how will it send the hello world? It will send the hello world on this, on a ephemeral port. It won't be able to send it on 80 because 80 is not open on your client. Whereas your operating system has got a bunch of ephemeral ports, which it allows communication to receive into your laptop or desktop or the client. Okay. So now there is one more interesting thing to this statefulness of security group. Okay. So now what happens is when you allow an inbound on port 22 on TCP on this particular source, right? By default, the outbound is also allowed for that. You don't have to explicitly mention here, right? For example, let me, I'm only restricting my outbound to TCP. I'm just giving some random port 56,790. Okay, that is the ephemeral port that I'm giving, and I'm giving the destination as some other destination, some 192, 168. Instead of 10.50, I'm giving 10.60/32. Okay, so that's the restriction that I have. Okay, so now you might wonder, okay, and also you might also look at giving a ephemeral port range for this 50, right? Otherwise, it won't be able to connect to that. Okay, so now you might wonder, you have TCP port 22 allowed in the inbound, correct? No, but in outbound, should we not allow that? Okay, because it is also making an outbound communication, right? So by default, in security groups, any rule that you create in inbound, that is also remembered for outbound. That is the advantage of security groups. That is why it is called stateful. Okay, that is also remembered for your outbound communication as well. So you don't have to explicitly mention that in for your outbound, right? It is remembered for your outbound communication. Okay, whereas in NACLs, that is not the case. I'm going to talk about NACL shortly. In ACLs, it is not the case. If you specify something in inbound, you also have to specify that in outbound, so that it can do a two-way communication with your inbound and outbound. Okay, that's the advantage of a security group. Okay, I'm just going back to the security groups. So you can specify allow rules, but not deny rules. Remember that. In security group, it is always only allow. By default, it is like deny. But you are specifically allowing only a few systems to, a few ports or few protocols or few systems to connect to your service. You can specify separate rules for inbound and outbound traffic, like what we did here, right? This is the inbound traffic, this is outbound traffic. This is inbound, this is outbound. Security group rules enable you to filter traffic based on protocols and port numbers, right? We did that. We filtered it by protocols and ports. Security groups are stateful. If you send a request from your instance, the response traffic for that request is allowed to flow in regardless of inbound security group rules. Responses to allowed inbound are allowed to flow out regardless of outbound security rules. Okay, read this very carefully. If you send a request from your instance, okay, for example, your server is connecting to client on a I'll just delete all of this. Okay, I'll just delete all of this. So now let's assume a fresh scenario where a server is trying to connect to a client. Okay, so now server is trying to connect to a client. Let's say it is all protocols, all ports 0000/0. Okay, that is the thing, right? Assume there is no inbound rules, right? But your server is actually making a call to your client. Server is trying to call your client on 5987. Okay, so now the return traffic also has to come back, right, from the client back to the server. Okay, on the same 5987, it has to come back. So now in this case, you don't have any inbound security rules. So through the virtue of statefulness, if server is making a call to client on 5987, security group also allows 5987 to come back. Okay, so that way you don't have to explicitly specify, it is remembered. You don't have to do anything, it is remembered, and then it should be able to send, the client should be able to send the packet back to the server on 5987, because that is remembered. That's why if you send a request from your instance, the response traffic for that request is allowed to flow, which is the response, right? This is request and return is response, always in a client server model, correct? The response traffic is allowed to flow in regardless of inbound security group rules. Okay. Similarly, responses to allowed inbound are allowed to flow out regardless of outbound security rules. Okay, so that is very important. When you create a new security group, it has no inbound rules. Therefore, no inbound traffic originating from another host to your instance is allowed until you add inbound rules to the security group. So inbound is definitely needed. By default, a security group includes an outbound rule that allows all outbound traffic. You can remove the rule and add outbound rules that allow only specific outbound traffic only. If your security group has no outbound rules, no outbound traffic originating from your instance is allowed. Okay, if you don't have this one, nothing is allowed to go outbound. There are quotas on the number of security groups that you can create per VPC. You can look at, so okay, so since it's a public cloud, AWS is a public cloud, and the underlying infrastructure is a shared infrastructure. AWS wants to ensure that nobody misuses it, nobody over provisions things, which basically prevents others from using the underlying common shared infrastructure, correct? So from that perspective, what it does is it sets limits on various different services. Okay, and you can always, there are some soft limits and hard limits. Remember those. Soft limits are those where you can reach out to the AWS support and you can request AWS support to increase the limit up till the hard limit is reached. Beyond hard limit, nothing can be done. It can't be increased. Okay, you have to find alternate ways to get your things done. You have to create multiple VPCs or you have to create multiple accounts and things like that. But at a VPC level, at an account level, there are soft limits and hard limits. Instances associated with a security group can't talk to each other unless you add rules allowing the traffic. Security groups are associated with network interfaces. After you launch an instance, you can change the security group that are associated with the instance, which changes the security group associated with the primary network interface. You can also specify or change the security groups associated with any other network interface. By default, when you create a network interface, it's associated with a default security group. So usually you must be wondering how security groups work, right? So when you create an EC2 instance, you have a network interface associated with it, right? Which is the NIC card, correct? You have a NIC card associated with your EC2 instance. So now security group actually gets applied to that NIC card, which is the network interface. So that any traffic that comes in will actually come through the NIC card, correct? That is the only gateway to the world, correct? So that way, at the gate itself, security group stops any unwanted traffic to reach your instance, so that nobody can, hack your instance, or no unwanted traffic will be reaching your instance. And you can give a description name to a security group and description to a security group. And it also has a unique ID. Every security group has a unique ID which starts with SG hyphen. Okay. Yeah. So that's basically on the security group. Please go through this page. This is very, very important. Try and understand every line of this, what I just read out, basics. Okay. This link is there in yesterday's assignment document. So please go through this. This is very, very important link, right? And you have to understand this. And if you see, these are some common security groups. examples that that are given. Okay, and you can practice security groups. Don't worry if you kind of don't get 100% understanding. It is usually uh, it is normal that you don't understand this on day one. Don't worry about it, but just understand, get your basics right. Okay, and keep experimenting, keep trying out things, so that you get your hands dirty, right? So that's the most important thing in any tech learning, right? In tech learning, you have to ensure that you experiment enough. You perform as many lab exercises as possible, right? Keep trying out. If you fail the first time, go back, read the basics again, come back again, apply the concepts whatever you have read, come back, and then try to see what mistake you have done. Okay, and when you're like see using security groups, if you're not able to connect your EC2 instance, go back to the documentation, read the basics, and apply the basics to what you have implemented. Then you will know what mistake you have done. Okay, so it's important that you keep trying out. Okay, so now let's go to network ACLs. So network ACLs are very similar to security groups. Okay, whereas right now in security groups, what did we do? We did apply a security group, which is this red box around an EC2 instance, correct? So, but in network ACLs, what we do is we apply the red box around the entire subnet. That is the difference between network ACLs and security groups. Network ACL. What does ACL stands for? Network Access Control List. In a short form, it's called NACL. Okay, you call it as NACLs. That's the short form of. I'm going to delete all of this. Okay, so in the case of security groups, you actually applied this red box, which is the security group, around the EC2 instance. It is applied at an EC2 instance level, whereas NACL is actually applied at a subnet level. If you see, I've got a subnet 1, which is 10.0.10/24. You're applying a NACL at a subnet level. Okay, so this is the NACL which is applied at a subnet level. Again, the principles more or less it applies very similar. You've got inbound and outbound, even in NACL. Security group is applied at the EC2 instance level. NACL is applied at the subnet level. So that NACL will be applied. NACL will be applicable for all the EC2 instances which are there within that subnet. Okay, So it's basically a network level security, right? Whereas if you see, security group is a instance level security. Now let me go back to my analogy of a gate, okay, in a gated community. Okay, you have a huge, big gated community, and there are 200 villas in that gated community. Okay, instead of apartments, there are villas in that gated community. So now this is spread across, say, 100 acres. Okay, across 100 acres, there are about 200 villas in that 100 acres. So now each villa has got a gate, and each villa has got a compound wall or a fencing. Now imagine that to be the security group, and each villa has got a security group of its own, which is the gate of its own, and only authorized persons can enter that villa. Similarly, the entire 200 acres of this group of villas, which is built by a promoter and which is managed by a society, is also has got a gate and also has got a complete boundary. The 200 acres is completely covered with a compound wall or a fencing, and there's a boundary. Again, to enter that 200 acres property, also there is a security guard waiting outside who is allowing only authorized persons to uh, enter the entire estate. Okay, and then once a person enters through that outside gate, they search for the villa that they want to visit. They go to the villa, and again at the villa there is a security guard, who's authenticating and authorizing your identity, and then he is again allowing you to enter into the villa. That is the difference between NACL and security group. Okay, so NACL has a wider impact at the subnet level. Whatever EC2 instances, that is the first gate. Only if you enter the first gate, you will be able to enter the second gate. Correct? Only if you enter the estate, the 200 acres of gated community estate, you will be able to enter the villa, right? If you are basically sent back at the main gate itself, you won't be able to re-enter. You won't be able to enter the individual villa, correct? So that way, security group acts as NACL acts as a layer around the entire subnet, where it can act as a firewall at a subnet level. Okay. A network access control list is an optional layer of security. So the reason why AWS is calling it as optional is, I mean, you can implement NACL or you can just leave NACLs as allow all. Okay, of course, in this example of the 200 acres property estate, you have a main gate, but the main gate is just Nam Kevasi, right? I mean, nobody is actually caring entering the main gate, right? Everybody is allowed inside, not a problem. Okay, so that's why it's called optional. But still, you need to have that main gate. Without that main gate, it is not possible. You still need to have, but in that main gate, you're allowing 0000 all. Okay, so network access list control list is an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more subnets. That is the key, subnets. You might set up NACLs with rules similar to your security groups in order to add an additional layer of security to your VPC. So, okay, let's look at some of the basics of NACL. Your VPC automatically comes with a modifiable default NACL. By default, it allows all inbound and all outbound traffic, IPv4, and if applicable, IPv6 traffic. You can create a custom NACL and associate it with a subnet, similar to security group, right? Security group also, you have a default security group, and then you also have a custom security groups. By default, each custom NACL denies all inbound and outbound unless you add rules. Same as security group. Security group also, you have to add rules, right? If you don't add rules, by default, it is all denied. Okay. Each subnet and VPC must be associated with a NACL. If you don't explicitly associate a subnet with the NACL, the subnet is automatically associated with the default NACL. Because it has to allow the traffic. You can associate a NACL with multiple subnets. You can create one NACL and associate it with multiple subnets. Similar to security groups also, right? Security groups also, you can create one security group and you can associate it with multiple EC2 instances. Okay. However, a subnet can be associated with only one NACL at a time. You can't associate multiple NACLs with a subnet. It can be associated with only one subnet. Whereas in the case of security groups, what did I say yesterday? Union. It's a union. You can have multiple security group and multiple rules associated with an EC2 instance. It takes the union of all the security groups rules, and then it allows the traffic to pass through based on the union. Okay, but whereas in NACL that's not possible. You can only associate one NACL with a security group. NACL contains a numbered list of rules. We evaluate the rules in order, starting with the lowest numbered rule to determine whether the traffic is allowed in or out of any subnet associated with the NACL. The highest number that you can use is 32766. So it's like in a ascending order. Okay, you start from 1, 2, 3, 4, or 100, 200, 300, 400. Whichever is the least, that number is first evaluated. That rule is first evaluated. Okay, that is very important. Okay, you need a numbered list of rules, and it's usually best practice to start with, like, say 100, then 200, then 300, 400, 500. So between 100 and 200, you want to insert some rules so that those rules takes precedence. Then you say 101 or 110, 120. So that way, before 200, your 110 or 120 rule gets evaluated. Okay, and a network has ACL has separate inbound and outbound rules, and each rule can either allow or deny traffic. Same as security groups, but the only difference is NACLs are not stateful. They are stateless. If you allow something in, you also have to allow that outbound also explicitly. Whereas in security group, that's not the case, right? When you allow, say, 22 in, 22 outbound is also allowed by default. Okay, a network ACL has separate inbound and outbound rules. Okay, network ACLs are stateless, which means that responses to allowed inbound traffic are subject to the rules for outbound and vice versa. Okay. Okay. Now let's look at NACL rules. You can add or remove rules from the default network ACL or create additional NACLs for your VPCs. When you add or remove rules from a NACL, the changes are automatically applied to the subnet that it's associated with. Now, what it has these are the parameters that you can pass to the NACL. Okay. Rule number. I told you about the rule number where it has to be in an ascending order so that the rules are also evaluated in the ascending order. Type, right? What type of traffic it is, like SSH or HTTP. What protocol? Is it TCP, ICMP, or UDP? Port range, which port? 80 to 22443. Source. For all inbound, it is source. For all outbound, it is like destination. Okay, and then either you allow or deny. Okay, which is not possible in security groups, right? In security groups, you can never deny. Whereas in NACL, you can deny. Explicitly, you can deny. For example, you are running a website, okay, and you're seeing some attacks happening from a set of IP addresses, like, say, from China. Okay, from China, somebody is trying to hack your website, okay, from specific set of IP addresses, maybe 5 IP addresses. The hacker is using 5 different set of IP addresses to hack into your a website. You figure it out, okay, through logs, and you figure it out. So now what you can do is you can go create a rule in NACL saying that source has these 5 IP addresses, okay, and port is whatever port that the hacker is trying to attack your application on, or you can block all the ports, all the protocols, all the ports, and you can say deny. So when traffic is coming from that specific source of 5 IP addresses coming from China, by default, NACL associated with the security group will drop the packet. Okay, so the hacker will no longer be able to connect to your system. Okay, he will get a connection timeout, or he will get a connection refused error at his end. So if he's trying to access or use a program from his end to hack your system, the program will start facing errors, or the program will crash at hacker's end. Okay, so that is the advantage of using deny. Whereas that's not possible in a security group. In the security group, you can only allow, you can never deny. By default, it is deny, but then you can only allow. In the rule, you can't specify allow or deny, correct? Whereas in NACLs, the advantage is you can deny a set of IP addresses to reach you, right? Imagine you don't use NACL, you're only using security groups, right? Your NACL is all allowed. Okay, you're not applying any rules to NACL. It's like the default NACL that you're using. In a similar scenario where a hacker is trying to hack your website which is running, and you have your security group. See, in the security group, of course, you have to allow 0000, right? Because it's a public website. Anybody can access your public website. It is your company's website. Let's put it that way. That's your company's website, and anyone and everyone will be able to access your company's website through internet, via internet. So in such cases, you see that there are these 5 IP addresses which are constantly trying to attack your website and trying to modify certain things in your website. In security group, you will never be able to block it, because in security group, what you would have allowed is you would have allowed protocol as HTTP, port as 443 or 80, and source as 0000. That's it. You're allowing 0000. And that 0000, you won't be able to say that exclude only these 5 IP addresses and allow the rest of the IP addresses. That is not going to be possible, correct? Because 0000 means any IP. Whereas in NACL, you can say that, I mean, you are still allowing 000, but at the same time, before you allow 000, you are also denying those 5 IP addresses. So first it will evaluate a rule which is having a lower number. In that lower number rule, you are adding these 5 IP addresses to deny. So the moment it hits that rule, for those 5 IP addresses, it will drop the packet. And then for the rest of the IP addresses, it will simply allow. Okay, that is the beauty of NACLs. So it is like a firewall. Okay, all of you must have heard of firewalls, right? Firewall devices. Firewall device actually works like this only. Okay, there are so many firewall companies that are there. Cyber security companies like Palo Alto Networks, Cisco firewalls. Okay, Fortinet firewalls. Okay, and there are so many firewalls devices that are there. Okay, so very famous ones are there. Okay, so now what firewall also does is firewall also does very similar thing, but firewalls are a lot more advanced. Firewall comes with a lot more feature sets to define more granular policies and things like that. Of course, NACLs are not a complete equivalent to firewall, but yeah, it can basically give you some sort of security and some sort of rudimentary protection to your subnet, the entire subnet, so that all the EC2 instances that are there in the subnet, they get. Yeah. Okay. So if you see here, this is an example of a NACL. Okay. This is an inbound NACL. This is an outbound NACL. So now the inbound NACL, we have got 2 rules. First is rule number 100, and then star is like default rule, the last rule, which will, if you don't have any number associated, first numbers will get evaluated. After numbers will get evaluated, then finally your star will get evaluated. Okay, if none of your numbers that you specify matches or satisfies any of the rule, then finally it will go to the star, which is the default rule. So 100 is one rule which is created where it is all IPv4 traffic, all protocols, all port ranges. Okay, you're allowing 0000, you're allowing basically. Also, you're saying the default rule is the same, but you're denying here. Okay, so now, as I said, NACLs work on the basis of the rule number where where you have it works on the basis of allow and deny. So what will happen is first this rule will get evaluated. So any traffic that is coming into your subnet will get allowed because this is the least rule that is there, correct? So it will not even hit this rule, the second rule, the deny rule. Similarly, you have outbound also where you have 100 and star. So here also what will happen is by default, this rule will get evaluated first because it has got 100. Now imagine you don't have this 100 rule, okay? Then every traffic that comes will get denied. Every traffic that comes will get denied. Every traffic that goes out will get denied. Okay. So the default network ACL is configured to allow all traffic to flow in and out of the subnets with which it is associated. Each NACL also includes a rule whose rule number is an asterisk. Okay, an asterisk is there, which is the star. So this rule ensures that if a packet doesn't match any of the other numbered rules, so these are all numbered rules. This is the not numbered. This is the asterisk rule. It is denied. Okay, this rule ensures that if a packet doesn't match any of the other numbered rules, it is denied. You can't modify or remove this rule. So this rule will be there. You can't modify or deny this rule. Okay, so let's do one thing. Let's do some quick hands-on with NACLs. I'm just going to pull up my system. Just give me a second. Okay, I have my EC2 console pulled up. Let me just connect to my okay. Okay, just okay. So I'm in my EC2 management console. Let me go to VPC. So this is where you can find NACLs. So I've got one VPC. Okay, I'm going to Mumbai region. We're using Mumbai region. Okay, and I've got a default VPC, and I've got my VPC here, which is 10.0.0.0/16. Then I'm going to subnets. Okay, I'll just filter by my VPC, subnets by my VPC. I've got like say 3 subnets: 10.0.10, 10.0.20, 10.0.30/24. Okay, these are the 3 subnets that I have. Okay, so now if you go down, I've got a NACL associated with the subnet. Okay, you can also visit the NACLs from here. Under security, you have security groups and NACLs. I'm just clicking on NACL. I've got one NACL, one default NACL associated with my VPC. Okay, and all subnets in my VPC are associated with that NACL. Okay, what does that NACL say? This is doesn't have a name. Okay, this is a default NACL. It is associated. It says default is yes, and it has a VPC association to it. Okay, let's look at some inbound rules here. Okay, so now it has got some inbound rules. What are those inbound rules? As I said, it has two inbound rules. One with the numbered rule, which allows, and there's an asterisk rule, which denies all the traffic, correct? So now in this case, as per the order of evaluation, it will first evaluate the numbered rules in the ascending order. Okay, and then whichever rule gets evaluated, whichever rule returns a positive, that rule will get applied. It will not even attempt to evaluate the rest of the rules. So similarly, you've got outbound rules where you have 100. Okay, so now let's do one thing. We have our EC2 instance. Let me quickly check if my EC2 instance is running. Yesterday's EC2 instance that I created. Okay, so where is my private? Let me check which region I created that in. Oh, sorry. I logged into a wrong account. Let me just re-log in. Just give me a second. That's a problem. If you work with so many accounts, you get confused. Okay, yes, I'm back. I'm on my EC2 console. Okay, and I've got two instances running, right, which we created the other day, a public EC2 instance and a private EC2 instance, right? Okay, cool. So now let's do one thing. For the public EC2 instance, I have my security group, which says allow, one is it allows all the traffic, then it allows like 22 TCP. So now what I'm going to do is let me just go to that security group and let me remove the all. Okay, I'll go to the public SSH all access. I'll go to the inbound rules. I'm going to edit the inbound rules and I'm going to delete this all traffic. Okay. I'm not allowing all traffic to my security group, which is associated with the EC2 instance. And I'm only allowing traffic only to come from this specific range from my Windows box. Okay, so I'll delete this also. I've got two rules. One is SSH, the other one is a ping. Okay. Okay, all right. So now let me go back to my NACL. Okay, so now let me just connect to my Windows instance and then let me check if I'm able to ping or connect to that. I'm just saying going to command ping. What is the IP address of that? (13 233 238 220), correct? Ping 13 233 238 220. Okay, it's pinging because the first gate is being allowed, right? What is the first gate here? The first gate is your NACL. so your first gate is NACL. I'll also put the security group around this. Okay. Okay, the first gate is NACL, which is the first red box around the subnet. Then the second gate is your security group, which is around the EC2 instance. Okay, so now let's look at how the communication would flow. So now in this case, I'm able to ping my EC2 instance, right? Because I'm allowing traffic to flow through my 34 to 25 1365. Okay, so if you closely look at the security group, I go to security groups, and then if I say public SSH all, I'm allowing source as 34 to 25 1365 / 32 to connect to SSH and to ping also. Okay, so that is the second gate. Okay, this is the second gate. But whereas first gate, let's look at the first gate. Let me go to NACLs. Okay, so this is the NACL associated with my subnet. Your inbound has allow all. Okay, so now allow all is given here. So now I'm going to basically change it. Let me go. I'll just delete this. Okay, by default, everything will get denied. I'm not allowing anything. I'm just denying everything. Now let me just go and try to ping my EC2 instance. Again, I'll ping my EC2 instance. You see this? It's request timed out. It won't work because even though I'm allowing something in the security group level, right? It's like this, right? The villa example. Even though I have told my security guard for my villa or my watchman in the villa to allow somebody, I have not told the main gate security guard to allow that same person into the premises itself, into the estate itself. So obviously, the main security guard is actually blocking him. He's saying, no, go away. I don't have authorization. Even though I've told my own security guard or my watchman to allow him inside. Okay, that's what is happening here. Okay, so you understand the difference very well, right? So now this is the main gate security guard. I am denying, I'm not allowing anybody to enter. I'm just denying. Okay, so now let me just go add that rule of 100 TCP. I'll just say all traffic 100 allow. I can say allow or deny. I'm just saying allow. I'll just say save. So now if you see, it is ordered as the first in the NACL list. Okay, I'm just going back to my thing. Let me try again pinging now. See, it's allowing. I'm getting a reply. Ping is working fine. Okay, so now let's do one thing. Let's go to the security group. I've allowed everything here. Okay, I've not denied anything at the NACL level, but whereas at the security group level, I will just go ahead and delete my ping. No, I don't have ping enabled in my security group. Only SSH is enabled. Let me just go on ping. It won't ping. It will request timeout because I've told my main gate security to allow the person inside, but I've not told my own watchman or my own security guard for my villa to allow him inside my villa. It will still send the traffic. So it has reached the VPC. So the only difference there is in the first instance, it was not even reached the VPC because it was even being blocked at the VPC level. But here in this case, it reached the VPC, it came till my instance, but in my instance, I'm not allowing it. So it is getting dropped at my instance, at an instance level. Okay, it reached my villa. It waited at the gate of my villa. But at the gate, the watchman did not allow that person to enter. So he is sent back. So similarly, out here also, it reached the EC2 instance, but EC2 instance is not allowing through the security group. Okay, so now let me add it back. Add a rule, all ICMP for this. Just say save. See, the changes apply immediately within a split of a second. Okay. Yeah. See, yeah, it works. It allows. Okay. So that's the beauty of security groups and NACLs, right? So NACLs. Let's do one more thing. I'll show you how the outbound rule works in the NACL. So now what I'm going to do is let me be more prescriptive. I'm not going to allow all traffic, right? Let me be more prescriptive at the NACL level. I'll just delete this. I'll just say add a rule, which is like rule number 100. I will say all ICMP. I'm only going to allow the traffic to come only from one source. Okay. And then I'll add one more rule, just say 200. I'll say this is for SSH. Where is SSH? Yeah, SSH port 22. I'm going to again give the same. Okay, so now what I've done is look at this very clearly. Rule number 100 is ping. I'm allowing ping. Rule number 200 is I'm allowing only SSH, only from this particular IP address. In outbound also, what I'm going to do is I'm going to just go ahead and delete this rule from the outbound. Okay, so now let's see what happens. And what the security group says? Security group says that, let me open security group in another tab, side by side. Okay, so what is security group saying? Security group is also doing the same thing. It is allowing SSH and ICMP from this particular source. And of course, outbound security group is all open because I don't want to restrict the outbound security group. Whereas here, inbound is the same. Okay, and then outbound is I'm denying all in the outbound. Okay, so now let's see whether it works or not. I'm going to ping. It won't work. You may ask, we have allowed ping in say NACL. It's allowed, right? And it has the lowest number also, lowest rule number also. And it is also allowed in the security group. Still, why is it not working? The reason why it is not working is NACLs are stateful. It is not, sorry, NACLs are stateless. It is not stateful. Okay. If I allow something, if I allow ping as an inbound, the ping on the outbound is not allowed by default. I have to explicitly allow the ping on the outbound. So I have to go to outbound. I have to add a rule that says 100, allow the ping. Okay, the destination can be this destination. Okay, so now you have explicitly allowed something in the outbound for this particular destination so that it can go back. Okay, so now let's again try. See, now it works. Okay, because the traffic that is coming from 34.225/32 for ping also has to be allowed in the outbound because so that there is a return traffic, right? I explained in the case of TCP, inbound and outbound, right? Because it's a TCP is a state full protocol where it is a very robust protocol. Okay, so now let's also try SSH. Okay, I'm just going to use my putty. Uh, 13, 233, 238, 220, right? Okay, I'm just going to open. Okay, it won't connect. It won't connect because I have allowed 200.
Specified in
Yeah, I've allowed SSH as inbound, but I have not allowed SSH in the outbound NACL. Okay. Whereas in the security, I'll also show you the same thing in security group. So now let me just go allow 200 SSH in NACL. SSH. Yeah, I allowed it in NACL. It's also allowed in this thing. So I'll just go. I'll again open putty. I'll load this. I'll say open. Let me quickly check the security group. The security group is allowed. Okay, it will still not work. You know the reason why? Because, okay, I spoke about ephemeral ports, correct? When you use programs like SSH or web servers and things like that, see, if you see, the client is making an inbound connection to Linux server on port 22, whereas Linux server is making an outbound connection on some random port to client like 5987, which is the ephemeral port. Okay, so now you have not allowed the ephemeral port in the network ACL. You have only allowed like port 22 in the network ACL. You have not allowed the ephemeral port. Okay, because TCP, the way TCP works, see, yeah, ICMP is a different protocol. ICMP works on like say UDP. It doesn't work on TCP. It's at a network level. Whereas TCP, it works very differently because in TCP, when a client makes a connection to the server also makes a connection to the client on a random port that client gives. That is called ephemeral port. Okay. So now what I'm going to do is I'm going to take the ephemeral port. I somewhere have the ephemeral port. Where is the ephemeral port? Okay. Ephemeral port ranges 1024 to 65,535. Okay. So what I'm going to do is I'm going to go here. I'm going to edit my NACL outbound rules. Instead of SSH, I'm going to add 200 custom TCP rule. Port range is this. Destination is this. So that I'll say allow. So this is the ephemeral port range that I'm giving, where my destination is, in this case, this. My Linux server is actually connecting to the client Windows server on some random port, 5987 or whatever it is, right? It could be within this range. So I'm whitelisting that entire range, but only for this specific destination. So now let's again try it. I'm going here. I'll load my public EC2 instance. I'll say open. Wow, it connected. It has connected to my EC2 instance because I have an ephemeral port range opened at the outbound rule of NACL because it's a TCP connection. Okay, in the case of TCP connection, you need to understand this very clearly that when client connects to the server, it will be on port 22 or port 80 or port 443 or whatever it is, right? But when the server in turn connects back to the client to send the acknowledgement back to the client or send the response back to the client. Inbound is request, outbound is response. This is request. Inbound is request, outbound is response. Okay, so now when the request comes on 22, whereas when the response is sent on some random port. But you don't know what that random port is allocated. That is decided during the TCP handshake process. That's the reason I'm asking you to read about TCP handshake so that you understand these concepts very well, right? But from a NACL perspective, you need to allow that ephemeral port range, which is for outbound on the NACL, so that you're able to send it. So now you may ask, is it not needed to add this range for this one? Okay, let's do one thing. Let's go to security groups. Okay, security groups, I've got these two inbound rules and I've got a default outbound rules, right? Let me actually delete this rule. I'm not having any outbound rules in my security group, right? So where in this case, when you don't have any rules in security group, what does it mean? It means deny all, right? Correct? When you don't have any rules in security groups, it means deny. By default, it's deny. And you're only allowing certain things from a source or to destination. Okay, so now let us see if my SSH connection is working or not. See, it is still working. I'll close this and reopen. I'll again open putty. I'll again load my EC2 instance. I'll say open. See, it's connecting. I'm able to still connect to my EC2 instance. Why? Because
It's stateful, sir.
it is stateful. Excellent. Okay, it is stateful. Because what happens is when my client is connecting to my server, okay, on say some port 22, it also, as part of the TCP handshake process, your Linux server has to initiate a communication with the client, correct? So now as part of the TCP handshake process, the client actually tells that my inbound port is 5987, right? So from that perspective, what happens is, see, the parent port here is like 22, okay? And the other ports that comes, right? Like say, for example, 5987 is part of the parent port. It's a child port, right? Because that is the, like in Linux, you have parent process and child process, right? So here also it's like parent port and child port. So that way, what you're doing is you are basically allowing any traffic to go back on 22 in the security group, which means 22 and any other ephemeral ports that you're allowing that to go through in the security group. So that is why it is called stateful. It remembers. You don't have to explicitly allow or deny that in your security groups. That's why if you see, your security group outbound has no rules, but your NACL outbound has got a rule of ephemeral ports of 1024 to 65535 because it doesn't remember. Your NACL doesn't remember. For NACL, each rule in inbound and each rule in outbound are uniquely identified or uniquely classified. Okay, so you have to explicitly mention rules in inbound and explicitly mention rules in outbound. Because in this case, I've got a explicit rule called 22. You're allowing 22 in inbound NACL. It doesn't remember this. It doesn't remember when it goes to outbound. You have to explicitly specify that, okay, outbound, please allow the ephemeral port range. Whereas in the case of security group, in inbound, you have specified TCP port 22 for a specific source. It remembers that anything associated with TCP port 22 and any child ports that are used as part of port 22 which is the ephemeral range, it allows it by default. It remembers and it allows it by default. That is the difference that you need to understand, because this is a famous interview question. Okay. What is the difference between security group and NACL? You have to say that security groups are stateful and security group is a instance level firewall. Okay. In security groups, you can only allow. By default, it is all denied. Okay. You can only allow traffic to pass through. Whereas NACL is a firewall at a subnet level, VPC subnet level. So you associate a NACL with a subnet. Okay. It affects all the EC2 instances that are there within the subnet, and it curtails the communication at a complete subnet level. And NACL is stateless. When you define an inbound rule, you also have to define an outbound rule for the NACL. Okay, you can't take it for granted that NACL will remember as part of the TCP connection, as part of the TCP handshake process. NACL will not remember, that, okay, you're inbound, you're allowing 22. So I need to still allow 22 or any ports associated with 22 as part of the TCP handshake process. All the other child ports or the ephemeral ports, it doesn't remember that. So you have to explicitly say that allow the ephemeral ports in the outbound NACL so that it can communicate to the client on the ephemeral ports, and the watchman or the gatekeeper knows that it has to basically allow the traffic to pass through. Okay, so do these exercises today. Okay, whatever steps that I gave, you can play this video, right? And you can follow the steps and you can just do these exercises today. Okay, I'm going to fill the form for today, for the assignment. I'll give you this so that you can test it out. Now, in 5 minutes, we'll get to the lab session. Okay, I'll answer all your questions that you have as I promised yesterday. Okay, so use the public. Give me 2 minutes. Let me fill this document and come to you. Today is 28th October. Okay, we learned about NACLs. Do this, and I'll also give you links about TCP handshake, ephemeral ports. I'll give you some links for this. Ephemeral ports. Okay, use the public EC2 instances created on the previous lab exercise. Okay, that you have done. Yeah, go to NACL. Navigate to VPC NACLs under security. Okay. Open the default NACL. You can also create new NACLs and you can associate that with your subnet. But that is also possible. Okay. Open the default NACL. Review the rules present. Okay. Modify the rule as follows. This is scenario 1. Okay. Scenario 1 is okay. Okay, so this was scenario 1, right? Where we deleted the allow. Okay. Scenario 1, delete the allow rule 100. Okay. from inbound. Okay, then try to ping your EC2 instance. Result is you should not be able to ping. Okay, so then scenario 2, add rule 100 all IPv4 and then give your source. And allow. Okay, add a rule, numbered rule 100 to allow ICMP traffic, ping traffic from your computer. Okay, so that screenshot will be like this. Insert pictures from file. Okay, so try to ping you should be able to ping. Okay, yeah, so next scenario is scenario 3 is go to outbound rule in NACL and modify the outbound rule as follows. So you're going to your outbound rule and you are basically deleting the allow rule. Okay, delete the allow rule. Insert pictures from file. Yeah. Okay, I've deleted the outbound rule because I'm denying all traffic, right? So what should be the scenario here? 10th is try to ping your EC2 instance. Result should be you should not be able to ping. Okay, because you have denied all traffic. Yeah, all outbound traffic at NACL level. Okay, then next scenario is scenario 4. Add a new rule in outbound NACL to allow ping traffic. Okay, I'm allowing a new rule. It says all ICMP IPv4 from the destination as to the destination as this one. Okay, so now it should allow. Okay, now try to ping your EC2 instance. you should be able to ping. Okay, then scenario 5 is, let's do SSH. Okay, add a new rule in inbound NACL to allow SSH. Go to inbound, edit inbound, add a new rule, say 200, say SSH from my source, allow. Okay, just follow these steps. I mean, you should be able to do it well, don't worry. Okay, then you're allowing 200. 200 rule is this, but try to SSH, try to putty to your EC2 instance. Result, you should not be able to putty because your outbound doesn't have the TCP ephemeral port range whitelisted allowed. Okay. Last scenario, scenario 5 is add a new rule in outbound NACL to allow the ephemeral port range. Outbound, I'm just adding 200 custom rule. What is the ephemeral port range? Is 1024 to 65535. Destination is only my destination. Allow. Insert pictures from file. Okay, so I've allowed 200. So try to ping. Sorry, try to connect putty. Result, you should be able to putty. Okay, let's see. We've done all of that. Let me close this. Let me first ping. Yeah, ping is allowing. Putty. Let me load it. So open. Yes, it's allowing. So all the steps that we have done is right. Okay. Also ensure that you have not changed your security group from yesterday to today. The security group still remains the same. Okay. The last one that you can do is you can edit your security group. The last exercise that you can do is, which is scenario 6. Scenario 6 is go to your security group and delete all outbound rules. And then try to putty to your EC2 instance. Result, you should be able to putty since security groups are what? What are security groups?
Stateful.
Stateful, sir.
Stateful. Excellent. Okay. Security groups are stateful. It should allow the traffic to pass out of security group. Since port 22 is open in the inbound SG rule, and it should remember that for outbound as well. Okay, when I say it should remember for outbound, it means that it remembers the ephemeral port range also. You don't have to explicitly open the ephemeral port range in the security group. Okay. Okay, so now this looks quite interesting and quite simple, right? But this can get complex as much as possible, right? Because when you in real time, when you're actually working on projects, when you're working on troubleshooting things, right? I mean, you should always keep the outbound security rules as open. Okay, don't don't play around with the outbound security group rules, because it can get really messy, and it can get, because when your applications are integrating with other applications, that's when it can really get quite interesting and quite difficult to troubleshoot. Okay, so but for now you guys can go try these. I'm going to share this documentation with you. I'm going to also point you to TCP handshake. I'll just take one more minute to give you the TCP handshake process. Yeah, Geek for Geeks is good. The explanations will be good. Read this TCP three-way handshake process. SYN, ACK, ACK. Okay, that's the TCP handshake process. Read this out. Okay, ephemeral ports. There are two links for ephemeral ports. One is for one is here. Look at this. Search for ephemeral ports on this. The other one is the wiki link also. Ephemeral port wiki link. Read these two links. Okay, I'm going to give you this. I'm going to share this in the chat. Okay, so now let me just open the floor. So now, okay, so